Hello and welcome to the first lesson in Module 2, which is about prime factorization. And today students will find the prime factorization of composite numbers. So a factor is a term I will be using a lot throughout this module. And a factor is just a number that is multiplied by another number to get a product. So for instance, 7 and 4 are factors of 28 because 7 is a number that when multiplied by another number 4, it gets a product, which is 28. Again, a product is the result of multiplication. Now, prime factorization is a number that is written as the product of its prime factors. So I'll give you a number, and then I want you to break it down into a bunch of prime factors and write it as a product. And we'll learn what prime factors are here. So a prime number is just a whole number that is greater than 1, that has exactly 2 factors, 1 in itself. An example of a prime number would be 11. The only factors of 11 are 1 and 11. Oh, excuse me. There are no other numbers, whole numbers, that we could multiply together to get 11. A composite number is kind of the opposite of a prime number. It's a whole number that has more than 2 factors. So for instance, 9 is a composite number because its factors are 1 times 9 or 3 times 3. So we have more than 2 factors when it comes to 9. That's why it's a composite number. Here you'll see a bunch of divisibility rules, and I handed these out in class to paste into your notebook so that you have them for reference when trying to decide if a number is prime or composite. The one note I'd add to this is for 2. A number is divisible by 2 if it is an even number, okay? If it's even, it is divisible by 2 and therefore automatically composite. So if it's divisible by any of these numbers, you know it's going to be a composite number. So we can see this in example A. We're going to decide if 19 is prime or composite. So I could go back and reference those divisibility rules on the previous slide to see if I can divide 19 by any of those numbers. So right now I know 2 factors of 19 are 1 times 19. I'm going to check, is it divisible by 2? Well, it's not because it's an odd number, okay? So then I would check, is it divisible by 3? And I would work my way through all of those divisibility rules to see, is 19 divisible by any of those numbers? Well, most of you would know that there are no 2 numbers that you can think of right now that multiply to be 19 except for 1 and 19. Therefore, it is a prime number. Okay, 20, right off the bat, I know is even. So therefore, right away, I know that 2 is a factor of 20. And in fact, 2 times 10 is 20. So I know that there are factors other than 1 and 20, which makes it composite. The number 13, I know 1 times 13 is 13, but I can't think of any other numbers that multiply to be 13, and therefore it is prime. And if you were to work your way through those divisibility rules, you would find 13 is not divisible by any of those numbers. And 138, though it seems like a large number, automatically I know it's an even number because it ends in an 8. And therefore I know it's divisible by 2, meaning it is composite. So even numbers are pretty easy to tell right away. Yep, they're composite. If you have odd numbers, you might have to do a little bit more work to figure out if it's prime or composite. So on the next slide, I have a couple for you to try on your own. So you could pause the video at this point and try these on your own. So I'm going to go through the answers here. 21 is not even, but it is divisible by 3. So the divisibility rule for 3 says if the sum of the digits is divisible by 3. So 2 and 1 makes 3, and we know 3 is divisible by 3. Therefore, 21 is divisible by 3, making it composite. And you might have known just off the top of your head, yep, I know that 21 has 3 times 7 as one of the factors, and you would know it's composite. 1,968 is an even number, so right away I know it's divisible by 2, and therefore it is a composite number. 31 is odd, okay, so I need to decide, can I think of any factors of 31 other than 1 times 31? And when I go through my multiplication facts, I can't think of any two numbers that multiply to be 31, and therefore it is prime. And if I had extra time, I would go through and I would check all my divisibility rules. I would see that 31 cannot be divided by any of those numbers in your divisibility rules chart. Okay, the number 2. Now, in order for a number to be prime, it can only have two factors, 1 and itself. Well, the only factors of 2 are 1 times 2, and therefore 2 is prime. And that often confuses people because you're thinking, oh, 2 is an even number though. But the only factors of 2 are 1 and 2, so therefore 2 is prime. Okay, we are actually going to write the prime factorization of a number now, and we're going to do this using a factor tree, or this says tree factor tree factor, okay? So we have the number 36, okay? And we want to write the number 36 as a product of a bunch of its prime factors. So I need to find the prime factors of 36, and this is the method in which you'll do this. So because it's a tree, we're going to draw a branch, okay? Branch off in two directions. And I'm going to think about two factors of 36 that I can use. Well, I know 36 is even, so I certainly know 2 is a factor of 36. And I know that 2 times 18 is 36. So I'm going to break 36 into 2 times 18. And then I pause and I say, is 2 a prime number? Yes, so I circle it. Okay. And then I say, is 18 a prime number? And the answer is no. So then I will break 18 into 2 of its factors. Well, I might think about breaking 18 into 2 and 9. I could break it into 3 and 6. It's up to you. You'll end up with the same results no matter which way you go. Okay, so 2 is prime, so I'm going to circle it. 9 is not prime, so I'm going to keep going. What can I break 9 into? Well, 3 times 3. And I ask myself, is 3 a prime number? Yes, it is, so I circle it. And is this 3 a prime number? Yes, so I circle it. And at this point, I've broken all of these numbers down as far as I can. So I ended up with a 2, a 2, a 3, and a 3. Now I want to write 36 as a product of all of these things, meaning I'm going to multiply them all together. So I get 2 times 2 times 3 times 3. Now the order in which you write this doesn't matter. You could do 3 times 2, 3 times 2, whatever. But there is a better way to write this, and that is using exponents. And I know you learned about exponents last year. So currently we have 2 2's, which means that is really 2 to the second power, okay, times, and then we have 2 of these 3's, so that is really 3 to the second power. So this is how I want you to write your answer using these exponents. Okay, so this is really, we have 2 2's and 2 3's. So that's how we would write our answer. Let's try another example. 280. A little bit bigger number, but I know it's even. Okay, so I could put 280 up here. I could break it into 2 times whatever its counterpart is. Now, if you don't know what 280 divided by 2 is, just ignore the 0 for a second, and you have 28. Think about what 28 divided by 2 is. Well, I know that's 14, but I have to add on that other 0. So 140 times 2 is 280, okay? And then I say, okay, yep, 2 is prime, so I circle it. 140 is not prime, so I keep going. And I know 140 can break into 2 times, well, again, ignore that 0, and we have 14. 14 divided by 2 is 7. Add back that 0. So 2 times 70 is 140. Well, 2 is prime, 70 is not, so we keep going. That breaks into 2 times 35. 2 is prime. 35 is not because it ends in a 5, so I know that it can definitely be divisible by 5, and in fact that is 5 times 7. Now is 5 a prime number? Yes. 1 and 5 are the only factors. Is 7 a prime number? Yes. 1 and 7 are the only factors. So I have gone as far as I can go as far as breaking down these numbers. So I'm going to write my answer as a product of these numbers. Now I have 1, 2, 3 of these 2's. So that's 2 to the third power times I only have 1 5 times I only have 1 7. So there is your answer, your prime factorization of 280. 2 to the third times 5 times 7. And I just have 2 more examples for you. How about 150? 150. Well, 150, we could go several ways. We know it's even, so we could split it into 2 and 75 if we wanted to. Or I know it ends in a 0, so it's divisible by 5. My brain automatically goes to 3 times 50. Okay, I know 3 times 50 is 150. Now I know 3 is prime, so I circle it. 50 is not, so I keep going. Again, I could break 50 into 2 and 25. I could break it into 5 and 10. It is really up to you, and it won't matter. Again, you'll get the same answer no matter which way you choose to go. So I'm going to go with 5 and 10. Okay, I know 5 is prime, so I'll circle it. 10 is not, so I will keep going. So I'm going to break 10 into 2 and 5. I know 2 is prime, so I circle it. 5 is prime, so I circle it. Okay, so I will write 150 as a product of its prime factors. I only have 1 3. I have 2 of these 5s, so that's 5 to the second. And then I have 1 2 times 2. Now, this is a perfectly acceptable answer. I typically like to write my factors in order from smallest to largest. So I would write 2 times 3 times 5 to the second, going from smallest to largest. I will accept either answer. Either one is good. And your last example here, 375. Okay, so I see that 375 ends in a 5. So I would say maybe I will start by dividing 375 by 5. Okay, and that might take a little bit of scratch work, which I'm not going to do right now. But if you did that scratch work, you would find it divides into 5 times 75. Oop, that was bad, 7. I know that 5 is prime, so I circle it. 75 is not prime, so I might break it into 5 times, oh, sorry, not 5 times 25. Now I have to start over. Sorry. 375. I break that into, and I don't, 375. I'm breaking it into 5 and 75. Sorry. So I circle the 5. And now I'm breaking 75 into 5 and 15. I know 5 is prime, so I circle it. I know 15 is not, so I keep going. I would break this into 3 times 5. I know 3 is prime and 5 is prime. Okay. So let's write this. I've gone as far as I can. Let's write this as a product of prime factors. Well, I have 1, 2, 3 of these 5s, so that's 5 to the third power, times, I only have 1 of these 3s. So 5 to the third times 3 is the prime factorization, or, again, you could put it in order and go 3 times 5 to the third, just smallest factor to largest factor. Okay, either of those answers are perfectly acceptable. Okay, and your homework for tonight is just a 15-question worksheet, the 2.1 worksheet, which can be found on Schoology.